Sometimes in engineering applications we have to find the area under a curve. For example, this is a curve and I want to find the area under this curve. Let's say I want to find the total area under this curve. So how would I do that? So the method I like to use is to take the data to AutoCAD and plot them. So how do I do that? I use concatenate function to join this with a comma in between and then this. So this is the data I need to plot on AutoCAD. So you just copy them, copy the data, take it to AutoCAD, PL, polyline. I want to join the points by polyline because for me, even if although this is a curved line, but if I join even if I join them by straight lines, the area under the curve will not be much affected because my data allows that approximation. Sometimes the curves may be too sharp and you will have to use the SPL command. But let me tell you the way which will apply to most cases. I'm going to use PL command. So PL, and then you paste that data over here. So you actually pasted the coordinates over here. So this is the graph. Now you see this is the graph, but what you need is you need the data on. You want for AutoCAD you need to complete this curve. You need a closed shape, so you have to draw a line vertically from this point and then horizontal line to the origin. So for that, what you need to do is you need to add the coordinates 0.19 and 0. See, for this point these are the coordinates, and then for the origin you have got 0, 0. So the same data is autofilled over here, so I just copy the whole data, and I need to just erase the first curve because it is incomplete. Sorry, delete. So I would say PL and just paste the data. So now it is a complete closed shape, so just go with the area command, select the object. Okay, so 0.0892, this is the data. So this is the area under this curve, 0.0892, because stress is in gigapascal and strain is unitless, so this final answer is in gigapascal. If you want to go from gigapascal to megapascal at this point, you can just multiply this answer by 1000. So now this answer is in megapascal. So now you've got the area under the curve in megapascal. The reason I worked with gigapascal for plotting the data is because if I use megapascal, these will be big numbers like 567 compared to 0.19. In that case, you see this vertical side will be too big and horizontal dimension will be too small, so I think you won't be able to see the curve. Okay, let me show you what happens if I use the actual megapascal units. So these are the data. This is the graph from where I got the data. So you just want to show you what happens if you use in megapascal. If you use this in megapascal and I just want to see what happens in that case, so I would go PL and I just paste the data, and then what happens is that let me see. So the curve is too high, so the graph is too high and very little dimension on the horizontal side, so you can't even see it properly. Okay, so you can actually see if the data is actually plotted correctly or not. So I'm just going to delete this. Now let me tell you, if this is a curve, and if you cannot compromise with straight lines and you have to draw curved lines, in that case you can just do it in parts. This first part is pretty much straight, so I would first, for example, say that I can draw it with a straight line. So I would say from this point until this. Okay, this is the coordinates for this point, I guess. Coordinates. Okay, so I need to zoom to see the curve, see the straight line first. So this is the line because now it is very much close to y-axis. So now let me just add the next part. Let's say this is the curved part and I want to do it in show it as a curve. So I would go SPL, spline command, which join the points by curved lines. So I'll start. So this is the last point of the first part. So I will start with this and then go up to the last point of the curve, actual last point of the curve, this point. Okay, copy and then bring it here. So you see this curved part is now here, and you will see the difference is very small for my case, but in case you have a curve which is too sharply changing its shape, so you got to use the actual SPL line. I need to add one more line for completing the closed shapes. I will just copy the last 3 coordinates. So this completes the curve, completes the object. Now I need to join them, because right now these are 3 different things, 3 different objects. I need to join them using join command. Join. I need to select this, and then this, and I need to zoom in to see the first one. Okay, so now these are joined. Just enter, and then you can go to the area command again. So I want to do it by selecting the object. Okay, so there you go, 0.0900. Okay, 0.090. Okay, for me this doesn't make a big difference. The earlier answer is very close to this answer, so it means for my case there's no point in, there's no use of doing the actual SPL line. I can go with polylines because my data is not that curved. So that's it for this area calculation.